Okay, guys, welcome back. Today we're going to do a quick review for mass percent, and I'm going to hopefully take a look at how that's going to show up or possibly would show up on your AP exam. So let's go ahead and get started. Okay, for our first example, let's say, for example, we have some regular table salt, sodium chloride, and it's usually represented by an empirical formula. Now, if you remember, an empirical formula represents the lowest whole number ratio of atoms in a compound. Ionic compounds always will use an empirical formula. If you'll notice that ionic compounds, when they're in a solid, the ions all just snap together, and so there's not really a defined number of sodiums and chlorides in the solid. You just have a ratio of 1 to 1, and so usually, or always, you will see ionic compounds represented using an empirical formula. Now, if we want to take the percent mass of each of the components of this sodium chloride, we can pull those apart. We can look at our periodic table, and we can find the molar mass that's on the periodic table. Now, this is going to be in either AMUs or grams per mole. The number's the same. We can use that for either unit. And it doesn't really matter because with percentages, your units cancel out anyway. So we get our total mass, and then we take each individual portion and divide it by the total to give ourselves a percentage. And we can see we have 39.34% sodium in this compound and 60.66% chloride. Now, if we want to take a look at a different compound, let's say propane, and this one's represented by what we would refer to as a molecular formula. Now, a molecular formula represents the actual number of each atom in a molecule. So we can see this could be represented by CH3 in its lowest whole number ratio, but typically covalent compounds use a molecular formula. Now, you can also see these represented with an empirical formula, but it's really not very common. Now, when you have your percent mass and you solve backwards for your compound, you will get the empirical formula, but we're not going to do that today. So if we want to do this, it's the same concept. We're going to find our total molar mass first. Looking at our periodic table, we can see that carbon's 12.01, hydrogen's 1.008. Of course, we have 2 of the carbons, 6 of the hydrogens, and that gives us a total of 30.07 atomic mass units, or grams per mole. It doesn't really matter which unit you use for this. And of course, we divide the total carbon by the total mass, and then divide the total mass of the hydrogen divided by the total mass of the entire compound. And it gives us 79.88% carbon and 20.11% hydrogen. And typically these, if you add the percentages up, one way to double check yourself, if you add the percentages up, they should always add up to 100%, or in this case, if you'll notice, they add up to 99.99%. They could add up to 100.01%, and that's because of the way you round. Sometimes your rounding will cause you to be plus or minus a 100th or so, but that's no big deal. That's just basically rounding issues. All right, so how would this show up on an AP exam? Well, if it's a free response question, you may have to actually solve it using the math that I just showed you here a few minutes ago. However, in a multiple choice question, it'll usually be in a little more simplified form. So let's take a look at a couple of those. So which of the following 6-gram sample would have the greatest mass percent of oxygen? Well, if we look here, it doesn't really matter how many grams of the sample we have. Percentages don't change based on the total mass. A percentage is a percentage. So this 6-gram part is really just extra information that you have to learn to weed through. So we're just wanting to find this compound that has the greatest mass percent of oxygen. Now, if we look, all of these have 1 oxygen in them, and we're given the molar mass. So if each of those have 1 oxygen, we know the mass of oxygen in each of these compounds is going to be 16. So if you want to find the one with the greatest percent mass of oxygen, you would find the one with the lowest molar mass. Now, you can physically, with your pencil and paper, because you don't have a calculator for this part of the exam, you can sit there and you can calculate the molar mass of every single one of these and the mass percent of oxygen for every single one. But it's better if you can learn these little mathematical tricks and understand that when you have the 16 on the top, and the smaller the number is on the bottom, the larger percentage it'll be. That's a very quick way to do this without having to do a lot of math. Let's take a look at one that's a little bit different. The mass percent of oxygen in pure glucose is 53.3%. So a chemist analyzes a sample of glucose that contains impurities and determines that the mass percent of oxygen is 49.7%. Which of the following impurities could account for the low mass percent of oxygen in the sample? Okay, so we have 53.3% in a pure sample of glucose, but we know that the actual mass percent of oxygen is 49.7. So that tells us that whatever our impurity is, it has to have less than 49.7% oxygen or mass percent oxygen. Why? Because you couldn't bring the average down to 49.7 if it were at 49.7 or above. You have to have something that's lower than that. So we could, just literally go down through here and calculate the percent mass of oxygen in every one of these compounds. But the first thing you should always do is look for the obvious answer without having to do any calculation. Now we can see there's one compound here that basically has no oxygen. So its percent mass of oxygen is going to be obviously 0. So it could be something that could easily drive down the amount of oxygen content in this whole sample if it is an impurity in there. Now, if you actually literally calculate the rest of these, you'll know that the ribose and the fructose both also are 53.3%. The sucrose is less than 53.3, but it's greater than 49.7. So it is not possible that it can bring down the percent mass of oxygen down to 49.7 because it itself is higher than 49.7. However, they're not going to try to trick you with multiple right answers. This is one where you should be able to just pick out the quick right answer based on the fact that it has no oxygen. So it could be a very legitimate impurity in the sample. Okay, guys, this was your very short review on mass percent. Hopefully this will be enough to help you get through this process. There would only probably be 1 or 2 questions that relate to mass percent on the AP exam anyway, although it should be ones that are easy enough for you to get. These should be some of the easier questions for you. If you like this video, please hit subscribe, hit the like button. If there's other topics that you'd like to see me review, you can leave it in the comments and I'll try to get up a video reviewing those topics as well. And I hope to see you guys next time.